Now let's start the lecture number 2. So let me recap what had been done in the previous lecture. So here we introduce two types of error which occurs in terms of hypothesis testing. So first type of error is the probability of reject the null hypothesis when it is true, and the second type of error that occurs is the type 2 error, that is the probability of accept H0 when it is false or the alternative hypothesis true. So these two error, now we have to find a test that will minimize these two error, but it is not possible that simultaneously minimize these two type of error. What we will do, we will fix alpha and we will find a test for which the beta is minimized, and beta is minimized, or alternatively you can say beta star equal to 1 minus beta mu, that is a power, so it is maximized. And what this beta mu indicates, beta mu indicate the reject H0 when it is false, that indicates the power of the test. So let us define the most powerful test. Okay, most powerful test. So this is very important thing, most powerful test. Among all tests, with a fixed size, that is alpha fixed, we determine the one which has the smallest type 2 error, or maximum power function, and then the test is called the most powerful test. Then we call the test most powerful test. So that's it. Now another thing is, when H1 when alternative, this is another definition, when alternative hypothesis, that is H1, is simple hypothesis, that means from the hypothesis H1 you can determine the probability distribution, that is called simple hypothesis. Then the power that is 1 minus beta, that is second type of error, is a constant, so we look at the MP test, most powerful test, when H1 is composite. Now when H1 is composite, then the power function will be a, if it is composite, then the power function, the power function, the power, then the power will be a function of, will be a function, will be a function of the parameter. So we have to find a test which maximizes this power function. This power will be a function of the parameter, so we have to find a test which maximizes this function with function, and such that the and such test is called uniformly most powerful test. So that's it. That is the thing. Now let's move toward the another thing that is very necessary. So what we will call a test, means what is the test. So if one wants to mathematize the concept of test, what is the definition of the test? So that's it. Let me write the definition of the test. A test procedure. So suppose phi is a test and x is a random variable, so phi x equal to 1, that means we reject the null hypothesis. Phi x equal to 1 means with probability 1 we will reject the null hypothesis if x belongs to the critical region. On the region of the sample space, if x belongs to there, we will reject the null hypothesis with probability 1, and otherwise we will accept the null hypothesis, or otherwise there will be no reason for reject the null hypothesis. So if x belongs to XRC or SA, this is called non-randomized test. Non-randomized test. Why it is called non-randomized? Because with probability 1 or 0 will either accept or reject. Now see, sometimes it is required that a randomized test. So what is a randomized test? Let me define it here. Randomized test, and this test required mostly in the cases of discrete random variable. For the discrete random variable we need such randomized test. So that test is defined as, this is test is a function of the variable. It will be 1 if x belongs to SR, or it will be P that with probability if x belongs to something and equal to 0 if x belongs to SA. This means if x belongs to certain thing, suppose A star, then with this means with probability P, we accept the test, accept the null hypothesis, accept the null hypothesis, and with 1 minus P we reject it. So that is the test, that is called randomized test. So let me give an example here. Suppose that we tossed a coin 3 times. So we toss a coin 3 times. Now we want to find the probability of head. What is the probability of head? So we first hypothesis is H0, the null hypothesis probability is 1/4, and alternative hypothesis is probability of 3/4. Now our test is, now let test here define the test. Our test is, so phi x, we will accept, we will reject the null hypothesis with probability 1 if probability is 1/4, means the chance of coming heads, chance of the outcome will be head is very less. That means if the head is less than, when we will reject the null hypothesis, when we will reject the null hypothesis, that means P equal to 1/4, the chance of head is less. When the head is, the number of heads, if the number of head is more than, if number of heads is greater than 1, and we will accept it if number is 1 or 0, or it is less than equal to 1. So this is the test. Now let us calculate that what is the type 1 probability, that is alpha, that is size. What is the size of this test? That is the probability. If we do so, what is the probability of occurring doing the first type of error? So the probability of type 2 error, that is reject the null hypothesis, when it is true. That means let assume that P is equal to 1/4, then what is the probability? What is the probability that we will reject? The probability of number of head is greater than 1, that means 2 or 3. If the number of heads in consecutively 3 round is head, then we will reject that test. That means what is then probability? That probability will be probability that head is 1/4, that x is 2 or x is 3. Then if x is 2 or x is 3, that is greater than 1, we will reject the hypothesis. So what is the probability under the P equal to 1/4, that this outcome will have this, either this or this outcome will occur? So that is the type 1 error, and it will be 3 1/4 square and 3 by 4 plus 1 by 4 its cubed. So that is 10 by 64. Now what is the second kind of error? The type 2 error. The type 2 error is P is accepting H0 when H1 is true. So that means P is 3 by 4 when we will accept if x equal to 0 or x equal to 1. That means let us calculate what is the probability of x equal to 0. That is 1 by 4 cube. That 3 consecutive tail outcome is 3 consecutive tails, and what is the 1 is 3 into 3 by 4 into 1 by 4 its square. That is again 10 by 64. So you say that this is the thing, that this is the beta, alpha and beta. Now let's see one example, one thing, that if we take sorry, let me check whether it is recording or not. It is recording, so that is fine. So sorry for the interruption. Now let's begin. So let us see another thing. Suppose that we will not take this state, rather we will take another test. So suppose our test is like this. We will reject H0 if x is 3 and we will accept H0 if x is 0, 1, 2. Now you will see that the alpha star, that will be probability under p equal to 1 by 4 null hypothesis. What is the probability that x equal to 3? That will be, let us calculate, that will be, since it follows a binary distribution, that will be 4c3 1 by 4 its cube and 3 by 4, sorry, it is 3c3, so 3 minus 3, so that is basically 1 4 its cube, that is 1 by 64. Now you see the value of size is actually decreasing, so that means it is a good sign. You will see at first, if anyone see at first sight, he or she may think that it is a good sign, that is alpha star type 1 error is decreasing. But what is the case with the type 2 error, or the power of that power of this test? Let us check beta star is, what is the probability that p is 3 by 4 we will accept the H0, means x equal to 0 or 1 or 2, that is 3c0 3 by 4 2 0 1 by 4 cube plus 3c1 3 4 1 1 4 square plus 3c2 3 by 4 its square 1 by 4 its square. So you will do, if you, so I think it is wrong, it is 1 I think. Now if you do this, you will get 37 by 64. Now you see the beta, the value of beta is not decreases as alpha decreases. In contrary, beta is increasing as alpha decreases. So that is a bad sign. So that is not at all good sign. That means if we change test, the we can decrease the value of alpha size, but we cannot decrease the value of the beta. So that's all. Now let's introduce another thing, and it is very important powerful tool in the realm of hypothesis testing, which is that Neyman-Pearson fundamental lemma. So one question is that, so as we introduce this concept that most powerful test, but one may ask that what is the way, or what gives you guarantee that most powerful tests exist, or another thing that what is the guarantee that, what is the way to find that test which is the most powerful test, what is the way to find the most powerful test. So that is a way that is called, we will use, by using this lemma, that Neyman-Pearson fundamental lemma, one can easily find the most powerful test for at least the simple hypothesis. So let's see Neyman and Pearson fundamental lemma. So let P0 and P1 P probability distribution P1 PB probability distribution, and P0 means that P0 means the probability distribution under the null hypothesis, and P1 means the probability distribution under the alternative hypothesis. Then for testing, this is the suppose that this is x, this is the probability distribution if null hypothesis is true, and P1 is the probability distribution if alternative hypothesis is true. If hypothesis is true, it's true. Now let me state the fundamental lemma. So for testing A0, P0 against GIST against the alternative for testing H0, that is P0, against the alternative hypothesis H1, that is P1, there exists a test phi and a constant k such that the expectation under the null hypothesis of the phi x is alpha, the size of the test, and the test is phi of x is 1, that with probability 1 will reject the null hypothesis when p1x greater than k p0x and equal to p. With probability p we will reject the null hypothesis when p1x is equal to k p0x and equal to 0 when p1x is less than k p0x. So that is our test. And how we will find the value of k, since for if we fixed the alpha, the size of the test, then from if under the null hypothesis, if we take the expectation of the test, we'll get alpha, and from there we can get the value k, and we can means we will means that test will be the most powerful test, and that test is this test is the most powerful test. This test is the most powerful test. So let me give you an example of this test, most powerful test, and the proof of this lemma is outside the scope of this lecture series. So I will so let me give you some example. Suppose example how you calculate. So let x be a continuous random variable with PDF fx is beta x to the power beta minus 1, x to the power beta minus 1, where x belongs to 0 to 1 and beta greater than 0, and it is otherwise 0 elsewhere. Now the hypothesis, null hypothesis, is beta equal to 1, and the alternative hypothesis is beta equal to 2. Now the most powerful test of size alpha. So you see that our hypotheses are simple hypotheses. So from this hypothesis one can clearly specifies the probability distribution function. So that means these are simple hypotheses. So according to the, let me apply here the lemma. So according to Neyman-Pearson lemma, Neyman-Pearson fundamental lemma, the MP test is reject reject the null hypothesis with probability 1. That means reject the null hypothesis H0 if P1x greater than K P0x, or you can say that P1x by P0x is greater than K. So that's all. Now we know what is the P1x. P1x is the distribution function under the hypothesis H1, and P0x is the distribution of the function under the hypothesis H0. So let me put P1. What will be the P1? P1 means if we put beta equal to 2, we will get the P1, and if we put beta equal to 1, we will get the P0. So let's put beta equal to 2. So here let me mention it clearly. P1x is the probability distribution function when H1 is true. P0x is the probability distribution function when H0 is true. So what is the P1x? P1x is beta is 2 e to the power 2 minus 1. So that is 2, sorry, this is not e, this is actually x to the power 2 minus 1. So that is x. And what is the value of P0x? That is, let's put beta equal to 1, then it is 1. Then what is the test? From here we will get that if reject the null hypothesis, if P1x by P0x is greater than K, then we will reject H0. So this means if x greater than K, reject the H0. Now so suppose this is 2x. Now the test is reject H0 if 2x greater than K. Now then what will be the expectation value of this test? That will be that probability 1, and when the we will reject with probability this, we will reject the null hypothesis with probability 1, and when this is true, and 0 when this is not true, 0 into something. Now this is not contribute, so and we know that this is equal to alpha, because from the Neyman-Pearson lemma we know that the expectation of this test is alpha. So expectation of this test is alpha, or you can say that what is the first kind of error. You can simply see from here that what is the first kind of error. So under the hypothesis H0 is true, what is the probability that we will reject the null hypothesis? That is that. So then what is the alpha? What is this? Is that under H0? This is that thing. Now see, under the H0, what is under the H0? What will be the probability distribution function? That is P0x will be 1 if x is, this is a uniform distribution function, x belongs to 1. Then this means P of x greater than K by 2 is alpha. This means 0 to, what is the probability that x will be greater than k by 2? So that will be k by 2 to 1 tx, and that is 1 minus k by 2. So this means 1 minus k by 2 is alpha. This means k is 2 into 1 minus alpha. So our most powerful test is the most powerful test is reject H0 if 2x greater than k, that is 2x greater than 2 1 minus alpha. So that means x greater than 1 minus alpha. So this is the, will reject the null hypothesis if this is true. This is the most powerful test. Now suppose alpha is 0.01, then when we will reject the null hypothesis? What is the null hypothesis? A null hypothesis, the beta equal to 1. When we will reject? We will reject if x greater than 1 minus 0.01, that is 0.99. So you see, this is actually a reasonable test. Will reject H0. You see the under H0, the probability distribution is a uniform distribution between 0 to 1, and what is the probability that under this null hypothesis that extreme point 0.99 will occur, the chance is very few. So that is the thing. And under the beta 2 you will see that the probability of getting an outcome that is larger than 0.99 is much larger. So that's why it is a reasonable test, and it is the most powerful test. That's it. So that's it. Now let's give another example. So another example of the most powerful test: x belongs to binomial 3p. So H0 is p is half and H1 is p is 3 by 4. Now find the MP for H0 at level alpha is 0.05. Now here again these two are simple hypotheses. These two are simple hypothesis, because from these two probabilities the distribution function can be easily find out. So that's why now we can apply here the NP fundamental lemma. You see what is the distribution function, that outcome, that x is the number of heads, will be 3cx p to the power x 1 minus p 3 minus x. and under the null hypothesis, what will be the probability distribution? F0 x comma p, it is p equal to half, so if we put half, then 3cx half to the power x half to the power 3 minus x, so that will be 3cx half cube. Now what is the probability distribution under the alternative hypothesis? That is 3cx, alternative hypothesis 3 by 4, 3 by 4 x and 1/4 to the power 3 minus x. So that is, you can write it in this way: 3cx 3 by 4 x 1 by 4 minus x 1 by 4 x cube. So 3cx 3 by 4 into 4 by 1 x 1/4 cube, so that is 3cx 3 to the power x 1 by 4 x cube. Now the MP test will be, MP test will be phi x is reject the null hypothesis with probability 1 if f1 by f0 is greater than k or equal to accept if it is less than k. Or suppose, or let me do another thing, or accept it with probability gamma, or reject it with probability gamma if f1 by f0 equal to k and equal to 0 if it is less than k. Now what is the f1 x by f0 x greater than k? That is 3cx 3 to the power x 1/4 cube by 3cx half cube greater than k. So that means, and you this is another constant 3 to the power x, and this is half cube, this is half cube, so this is another constant. So you can consider this constant as we can take this constant in right side, and you can make another constant, and if you take log both sides, you will get x log 3 greater than log k0. So you again, this is a constant, we can adjust this constant in the right hand side, you will get x greater than c. So if x greater than c, we will reject the null hypothesis with probability 1, and if it is equal to 1, then we will reject the null hypothesis with probability gamma, and if less than k0, will accept the null hypothesis. Now what is the alpha? The value of alpha will be expectation under the null hypothesis of phi of x. So let me do that. So with probability 1, we reject this. So with probability 1, what is the probability under h0 that x greater than c? And with probability gamma, we reject it again. So with probability gamma, we reject it when probability under h0 x equal to c. Now let's calculate it. So we know that under the h0, what is the probability distribution? And this is this, so we can write it in this way. So this means p under the 0 x greater than c plus gamma p0 x equal to c is 0.05. Now we know that the probability distribution x equal to null hypothesis. What is the probability distribution? That is 3cx half cube. So that means it is summation of x that is greater than c, 3cx half cube plus gamma into 3cx. So this is c, 3 c half cube equal to 0.05. Now if you check by putting, since here x can take c should be an integer, you see that this integer. So if we will put c equal to 1, 2 and 3, and you will see that this equation will be satisfied with c equal to 3 and gamma equal to 0.4. Let me put it here. If c is equal to 3, if c greater than c is greater than 3, that is greater than 3, then it will be 0, and this is actually, this is 0.4 and this is 1, and this will be 1 by 28. So you see this is 0, because c cannot x cannot take value, because x can only take value 0, 1, 2, 3, and c greater than, that means 4, it cannot take, so it is 0 basically, and this means 0.4, 4, 1 by 8, that is 0.1 by 2, so that is 0.05. So you see at c equal to 3, gamma equal to 0.4, this equation satisfied. So this equation satisfies only when c equal to 3 and gamma is 0.4. So that means, so the MP test is that reject the null hypothesis when x is 3. That means you will not reject at all with probability 1, but with probability 0.4 you will reject the null hypothesis if x equal to 3, and if you cannot reject the null hypothesis if x less than 3. So this is heavy biased, this test is heavy biased. So here in this test we are saying that we will only, every time we will accept the null hypothesis and we will reject the null hypothesis only if x equal to 3 but with probability 0.4. So that's it. And in the next lecture we will again see some other exercise and how to find the mean and standard deviation of the normal distribution with this test. So that's it for today's lecture. So